as we continue our review, we are picking up our game. Quamesis is trailing right now. They have 47 points, but Kreeftel has 56. So Kreeftel is currently leading by 9 points. So Quamesis has to dig themselves out of a hole. And we will start with Quentin and Ethan. If you would take out that paper that you've been using for review. Don't forget notebooks will be due tomorrow after the review time. When you get ready to take your exam, that'll be in lesson 173. So, gentlemen, on the front row. What term describes the set of all points, and only those points, that satisfy a given condition or conditions? If you were John the Baptist, you'd be getting hungry right now. Loci, locus, a loci, and loci is plural. Locust and wild honey was what John the Baptist did. Anyway, hey, you don't get the references, I can't help you. Let's see, next two. Because a locus includes all points that satisfy a given condition, we say that a locus is
immiscible.
Square.
People are big about this today in society. Next two?
Right.
Inclusive. Inclusive. A locus is inclusive.
What does that word mean?
Includes everything that satisfies. We would say, though, of course, class, that a locus also, because it only includes points that satisfy a condition, a locus is also exclusive. All right, let's see. Back row gets their own question here. Trying to think if this is a good one for competition. May not be. Let's do some class things and then we'll come back to you too. So if we were to have the locus of all points, a given distance from a given line, a given distance from a given line, what would that locus look like? Anyone?
Two straight lines.
Two straight lines, parallel, one on either side, the given distance away. All right, what about if we wanted that same given distance but from a given point instead?
Circle with that given distance as the radius.
And the
Center is the midpoint.
center as the given point as center. So we can't just say a circle with that given with that distance as radius, because there you go, but it's still not that distance from this point, right? So both things require that distance as the radius, but the point as the center. What if I had an angle, and I wanted to find all points equidistant from the sides of the angle?
Angle bisector.
The angle bisector. If I had, no, we're just kind of reviewing real quick and then we'll get back to the game. If I had two parallel lines, I wanted the locus of all points equidistant from those parallel lines.
One straight line midway between
Parallel to, right, straight line midway between parallel to the two given lines. If I were to have a couple of points, and I wanted all points equidistant from two given points. Good, the perpendicular bisector of the line between the points. And let's see, I think there's one more. If we were to have a couple of intersecting lines, and I want all points equidistant from those two lines. The bisector of each of the angles, or we could say the two lines that bisect the pairs of vertical angles. So make sure you review over loci as well. Of course, compound loci would just be two or more conditions at the same time. We'd see where the possibilities intersect to get a number of points. All right, back people. What term describes a comparison of two values? Front row. Ratio. A ratio is a comparison of two values. All right, front row gets their own question. What term describes the second term in a ratio? Consequent. Consequent. And next to the first term in the ratio. First term in a ratio. Back row. Antecedent. Front row. An equality of two ratios.
Proportion.
That's a proportion. Next to the second and third terms of a proportion.
It does.
Second and third terms.
Mean proportional and third, the fourth is the fourth proportional and the mean proportional, right?
What do we call the second and third terms collectively in a proportion?
Oh, the extremes.
Back row. It's the means. I don't know if I'll give a point for that. Back row gets their own question. The means. First and fourth term would be the extremes. All right, back row. If the means are equal, then we have a... I think Jamie finished first. You started at the same time. I think Jamie finished first. If we have equal means, the fourth term of the proportion is called the third proportional. What is, this is going to be a fun one, what is the fundamental property of proportions? What is the fundamental property of proportions?
Extremes
Product of the extremes equals the product of the means. All right, back row. If I were to take this proportion, I could change the way it appears through what's called a transformation. There are several different transformations. Which transformation is this?
Alternation.
Front. Inversion. The inversion transformation, both of them got flipped. All right, next two, middle two. What's that? Which transformation is that?
That was inversion.
Back row. Anyone? That's alternation. Notice these two switched places. It wasn't a double flip, but the extremes switched places. We could have also switched the means for alternation. We could have switched both of them, but as long as the means just trade places with each other, or the extremes, or both, that would be alternation. All right, front row. You get your own subtraction transformation. Good. You saw it coming up on the board.
Addition. Multiplication. Subtraction. Multiplication.
Square transformation.
Back row.
Square everything.
The power root transformation. We did square everything. You're right. The power root transformation. Point for that. All right, no point for that because you didn't get the name, but you got the idea about it. All right, let's move on. I'm sorry. I don't know. You'll find out. If we have this picture.
First of all.
This is going to be kind of a hard one because we're actually in the middle row here. No, that was yours. It's back row. But I think this is just a hard one to do for points. Class, let's say the proportions together. Bottom is to top as bottom is to top. Whole is to bottom as whole is to bottom. Whole is to top as whole is to top. Again, assuming that line was parallel, those would be true. If they are true, then the line is parallel. We bisect an angle. What's the proportion, class? Segment is to segment as side is to side. Even if we had bisected an exterior angle, then segment is to segment as side is to side. Sure, don't actually ever erase the points along with that. Equatus has none. How did that happen? All right. All right, here we go. Back row, we've got a question for you. Polygons that have the same shape, but not necessarily the same size. Similar. Remember, you can answer before I stop talking. If polygons are similar, then their corresponding angles will be equal. Not you.
Not your turn.
Next two. If two polygons are similar, then their corresponding sides will be
equal. Parallel.
Is it perpendicular?
Back row?
Proportional?
I think she finished ahead of you again, Kendall. Proportional. Okay, front row. If two polygons are similar, then their corresponding sides will be, as the ladies in the back said, proportional. And that means that if you took the ratio of any two corresponding sides, it would be the same ratio. We would call this the ratio of similitude. Well, Poemuses was doing well.
Yeah, it's fine.
Let's see. Let's help Poemuses out. Genesis. I'll give you a chance to earn a free point here. If you can give me at least 4 of the 6 ways to prove two triangles are similar.
Is this like if their angles are?
All right, we're going to give it to Chris. You got your chance for a free point.
Angle. SAS. Angle, side angle. No. Acute angle and right triangle.
That is 4, so he gets the point. What are the other 2, anyone? No point. Side, and leg. Where again, legs and sides are proportional, the angles would be equal. So those are 6 ways to get triangles similar. Let's see, let's go to the back row now. Actually, let's say this together as a class, and then we'll get to the back row in a minute. CASTE, what does it stand for? Corresponding angles of similar triangles are equal. And then CSSTP stands for corresponding sides of similar triangles are proportional. All right. We will eventually get to you, back row, sorry. If we have a right triangle and an altitude is drawn to the hypotenuse, 2 proportions in words because there are 1, 2, 3 similar triangles. What are the 2 proportions? Say them with me. Segment is to altitude as altitude is to segment. Segment is to leg as leg is to hypotenuse. Let's say that one again. Segment is to leg as leg is to hypotenuse. All right, so make sure you know those proportions. All right, back row. What relationship exists between the 3 sides of any right triangle? If a triangle is a right triangle, then this relationship will exist between the 3 sides.
The square of the legs is equal to the square of the hypotenuse?
The sum of the square of the legs equals the square of the hypotenuse. I would have taken c squared equals a squared plus b squared, or you could have said Pythagorean theorem. Any of those would have worked. And that would have been, I was thinking Pythagorean theorem is a quick way to say it, but yes, you got it out there. Good. Okay. I say, hush, Kendall. It wasn't. What term, front row, describes the sum of the sides of a polygon? Next 2.
Say it one more time.
What term is defined as the sum of the sides of a polygon? Perimeter. All right.
Square.
Next 2. Actually, we'll do this one together as a class, and then we'll get to you 2. If 2 polygons are similar, what ratio exists between their perimeters? Perimeter, good, ratio of similitude, so that we could say perimeter is to perimeter as side is to side. Okay, perimeter is to perimeter as side is to side. Here we go. All right, back row. What term is defined as the number of square units contained within a geometric plane figure area? Is correct. Front row. What term describes geometric plane figures with the same area? You sound like it's some level of confidence in it. Equal figures have the same area. Feign confidence. All right. We'll do some formulas. We'll see who can spit out the formulas the fastest.
Everyone?
No. We're still in competition.
love
So I only
these.
have to listen to 2. All right. So here we go. Formula for the area of a trapezoid.
TR equals half of B1 plus B2.
TR equals 1 half B1 B2. No.
TR equals half of H times B1 plus B2.
There we go. TR equals 1 half H times B1 plus B2.
Oh.
All right. Next 2. Back row. Formula for the area of a square.
SQ equals S squared.
Square.
Tie.
Square.
Which is basically meaningless, but I'll do it anyway. All right, front row. Good job, ladies. Formula for the area of a triangle.
P equals 1 half BH.
1 half BH. All right, next 2. Formula for the area of a parallelogram.
PH equals BH.
PL equals BH. Is that wrong?
He got the BH part first by a long shot, and even corrected the PL. I'm going to give it to Chris. Let's see, next 2. Formula for the area of a rhombus.
RH equals 1 half D1 D2.
Tie. All right, front row. Formula for the area of a rectangle.
Rectangle is BH.
What'd you say?
Rectangle?
Rectangle equals BH.
Rectangle.
R equals BH. This is something we need to review next too.
Fun.
Without looking back, our
Okay.
special triangles. In a 45, 45, 90, what is the length of the hypotenuse?
X times square root of 2.
X times the square root of 2. Next 2. In a 45, 45, 90, what's the length of each leg?
X.
X.
Why?
Next, front row. In a 30, 60, 90, what is the length of the long leg?
2x. X. X square root of 3.
Yeah, okay, no point. X squared of 3.
What?
You've already exhausted them all. The long leg is X times the square root of 3. No point.
I was gonna let him
That's
go.
the long leg. All right. In a 30, 60, 90 next 2, what is the length of the hypotenuse?
2x.
2x.
Thank you, Brad.
Get good, kid.
And of course, class, the short leg would be X. For similar figures, back row, what ratio exists between their areas?
Similar.
The A is to A1 as, or A1 is to A2 as S is to S.
Front row.
Areas
Areas to area, side squares to side square. In other words, the square of the ratio of similitude. The square of the ratio of similitude. Class, say it with me. Area is to area as side squared is to side squared as perimeter squared is to perimeter squared. You did, you said it
How did
all.
you spell it?
Don't start. I'm starting.
I thought by myself.
Alright, and I think
Want me to expose you?
that just about wraps up the terms review.
Yes.
And that does wrap up our time today. Now, we do still have some math that we're going to do. We've got a 30-minute review right before the exam tomorrow. I'm going to actually put some problems on the board, and we'll continue in our competition. But as of now, Creeftel added 16 more points to go up to 72. And Quamesis got 14 points, so they fell 2 further points behind.
Yep.
Yep, go ahead, Alan.
I tried to carry.
Yeah, 14 points. They're at 61 points.
Hey.
So we've got a little work to do, Quamesis. Otherwise, Creeftel will take the victory tomorrow. Again, notebooks due tomorrow. Make sure they're ready to go. Exam tomorrow after the 30-minute review time.
Crispy carrot.
And you are